example in this comes from the book. It's problem 19.3. Okay, so if we had H2O liquid turning into H2O gas, what would happen?
Go up.
It would go up
So
because
entropy would increase. We
Yeah.
have a positive change in entropy, right? Okay. What about
It was a chain for the thing.
when
Alright, what does that represent?
It would go
increase
down.
in moving particles.
it would go down,
What's happening in this reaction?
becoming a
Oh.
It's precipitating, right? So when you form a precipitate, what's happening?
Less freedom.
Less freedom, because now the ions are bonding with each other. You're going from aqueous movable ions to solid that can't move. So this would be a negative change in entropy. Okay? Alright, what about this one? Gas yields 2. Okay. Rust.
More freedom? No, wait.
Yeah.
Why decrease?
when they go down.
Because oxygen is added and therefore it's
Yeah.
no longer a gas.
So you started with a gas, there were lots of particles.
Yeah.
You could also look at it in terms of moles. We started with 7 moles of things, and now we only have 2 moles of things. So we're making bonds, we're basically keeping those things from moving around. So negative delta S. Okay, one more. Nitrogen
This one will
gas
probably be positive just by 66.
plus oxygen gas.
Never go by statistics.
Yeah,
Gas.
positive.
I don't,
Or you
would that
can
change?
SAT.
It would go down because you're reducing the number of moving particles because they're bonding.
No, it would go up.
Can
Yeah.
it be the same?
It can be the same, because like you have 2 moles of gas making 2 moles of gas, right?
That was,
You're breaking a bond between nitrogen, and you're making a bond between nitrogen, oxygen, right? So you're really not changing the entropy here, it would be the same on both
there would
sides.
just be nothing.
Basically, that's only
Yeah, there
one
wouldn't
question
be a
answered.
change in entropy.
Yeah.
In chemistry, in the field of chemistry, what's the
Because
purpose
of
of
math.
measuring entropy? Like,
And so on Monday, we're going to take delta H and delta S and use them to find what's called delta G, which is Gibbs free energy, and that basically decides if a process is spontaneous or not. Like if it'll happen by itself or if you have to do something to make it happen. So it all kind of comes together in the end. Okay. Now the one way that you can actually calculate delta S, and if you have one of your white textbooks in front of you, open it up to Appendix C in the very back of the book.
Calculating changes.
Okay, find Appendix C.
No.
It's right after Appendix B,
Come on, Sam, it's right after B,
before D.
before D.
you know, there was this one time in kindergarten where my teacher told me I need to learn my alphabet. Never did it.
That's a suck.
Okay. So Appendix C gives you a whole bunch of information. It gives you the heat of formation, it gives you the delta G of formation, it gives you the entropy of formation. Now, real quick, what are the units of entropy?
Positive and negative.
No, units.
Joules.
Moles.
Kelvin.
Kelvin. Okay, so they're joules per mole Kelvin, where most things we look at are in kilojoules, right? So entropy is in joules, and when we get to Monday's calculations, that plays a big part in that because we have to pay attention to what our units are and make sure they match. So just like you can use heats of formation to find the heat of a reaction, we can find the delta S for a reaction by looking at the S of products minus the S of the reactants.
Does the degree sign stand for of?
That means standard, right? and when you look at the chart, standard means, in this particular case, 25 degrees Celsius. Yeah, so if the reaction's at 25 degrees Celsius, then these variables hold true, okay, and these constants hold true. So, let's look at our example. Nitrogen gas plus 3 hydrogen gas yields 2 NH3 gas. Now, just looking at the reaction, would you expect the entropy, the change in entropy to be positive or negative?
Positive.
Neutral.
We're
Oh wait,
going
no, negative,
from
because you have 3
4
moles.
moles of gas to 2 moles of gas. So we're creating extra bonds, so